So we can get a bit more of an accurate picture of the subtalar joint. I'm going to tell you now how the articulations are actually shaped. So remember, we have the inside and the outside articulation, and they have different curves to them, right? So they form like a sort of S or a wave shape going in different directions. Now that's going to have effects when we look at the biomechanics, but for now, if you just look at your left foot, and you can imagine now the outside articulation, so it's curved this way, and the inside is it's curved this way, right? Convex or concave would be depending on which bone we were looking at. But the angle of these articulations is actually to the outside of the body. They're more or less parallel, so they're not curving like that, but they're more or less parallel and turn towards the outside of the body. So see if you can give your heel bone a wobble and your talus, starting to imagine the sustentaculum tali. And so that part would be on the heel bone, what's actually forming the little ledge that holds up the talus. That part of the bone would be, or that part of the joint would be concave, and then the talus that rests in it would be convex. So see if you can imagine wobbling that, and think now that the angle of that joint is a little bit outwards, maybe towards your pinky toe. And see if you can imagine creating space in that joint as you pull the heel down and the talus away, almost opening them like a book, and then close them back together. And think about those joints, or that joint, opening and closing, creating more and less space. And then you can, in your mind's eye, reverse to the outside articulation. So on the heel bone side, the calcaneus side, it's going to be convex, and it's going to be pointing to the outside of the body once again. And then the talus that fits on top of it is going to be concave, resting on top. So then you can picture in your mind's eye, that's more or less under the upper curve of the talus. So you have the upper curve of the talus, which is pretty much pointing straight forward. It gets wider, we've talked about that, but it's pretty much going straight forward. And then the outside articulation, which is beneath it, is not going to be in the same direction, even though it's kind of the way I presented it in the beginning. It's actually going to be curved, not curved, but a little pointed in the direction of the outside of the body. So picture now, as I put my hands are now creating the top and the bottom of the talus. And then I'm going to grab the heel below and move the space of the outside articulation. And I can do it like a book, or I can turn the bones like a twisting motion, like gears. And there's not a lot of play in that direction, but that play will be important, and we'll look at that. That's the movement we're really going to work to embody in later videos. So then go to your right foot, and you think about the outside articulation from the heel bone side being convex, and the inside articulation being formed by the sustentaculum tali being concave, and then the talus fitting onto each of these bones. So start by wobbling and picturing the inside articulation, creating, let's see, curve my foot, creating space here. So this is my talus, this is my calcaneus, I'm doing this. And then see if you can picture the outside articulation. So you can think about the top of the talus going straight forward, and the outside articulation beneath it pointing to the outside of the body. And you have the heel bone connecting to the talus. So now I can open it like a book, or I can create a little bit of a twist, which is actually going to be a sliding motion. Okay. If you enjoyed this video, sign up for the InBody Space newsletter and share the link with a friend. You can also find original content on Facebook and Instagram.